Can someone confirm?
It's visible, sir.
So today we will be discussing about the electric vehicle charging infrastructure for green mobility. As you all know that uh, the future research challenges and the future trends in the electrical sector are mainly towards the electric vehicles as well as the renewables. We will be discussing why we are adopting to the electric vehicles and the renewables, and what are the major challenges present in these areas, and how to overcome these challenges. So the brief overview and the flow of the presentation will be with the current scenario of solar and EVs, what the Prime Minister has taken the oath at COP26, and what is the architecture, what is the need for adopting solar and EVs, what are the challenges present in them, and how we have some of the challenges are mitigated, and what is the way forward ahead in overcoming these challenges, and integration of these solar and these electric vehicles, which is a solar powered EV charging station, uh, which is the best solution for the green mobility. Coming to the current scenario of solar technology. So as of 30th November, in India, we have an installed capacity of 408 gigawatts. Over the 408 gigawatt composition, 166 is of renewables. So if you see, we have out of 408, we have around 204 of coal, gas is of 24 gigawatt, nuclear is of 6 gigawatt, and combined renewables and hydro is of 166 gigawatt. And in that measure, we are 166 gigawatt of renewables. We have 60 gigawatt of solar and wind of 41 gigawatts. Why we are adopting more solar is it is available everywhere, and it is a inexhaustible resource which is present everywhere in the world. You can install them on the rooftops, you can install them even on the street lights, you can install on the water beds. So the feasibility of installation is much more when compared to the other renewables. So out of 166, we have other resources also, which are biomass, hydro, which is of 46 gigawatt, and uh, remaining waste to energy conversion as well. So uh, in India, we have the highest solar power generation potential, which is present in Rajasthan, because the potential in Rajasthan is more uh, when compared to the other states. So people are trying to invest in such states. And if you see the even the railway stations, they are trying to convert it into the solar power, because we want to meet much of it through the renewables, and we want to avoid the fossil fuel based generation. So in India, we have the first railway station which is run completely by solar, which is the Guwahati railway station, and the installed capacity of it is around 700 kilowatt peak. So we can call this railway station as a net zero railway station, because the meaning of net zero is uh, how much we are consuming annually, and if we are able to generate that much amount of energy from the renewables annually, then we can call it as a net zero um, building, or a net zero, we can call it as a net zero building or a net zero railway station. So here the installed capacity is able to meet all the requirements. So you may get a doubt that our installed capacity is 700, and our connected load is 700 kilowatt load. So how every day you may not generate the same amount of power from the renewable source. Why? The reason is the renewables are intermittent in nature. So that is the reason why we are taking annual basis of calculation to show whether uh, over in 1 year we are able to meet our complete energy requirement from renewables or not, because in summer the power generation from solar may be to its rated value, whereas coming to winter and raining, the power generation will be very less in those days. So when we are designing the solar plant capacity, we will design in such a way that we will keep all the aspects of seasonal variations, as well as the shadowing. All these aspects we take into our consideration, and the even the load demand will be fluctuating, because even some duration we keep the loads on, and for some duration we keep it off. In summer the ACs will be turned on, whereas in winter these ACs we do not turn on. So the overall load profile of our station itself or the building itself is not constant. So the load demand itself is varying, and the power generation is also varying through seasons. That is the reason why we are to call it as a net zero. We will take the overall annual analysis. Next, this is the, if you see, here we have the western region, and this is the solar region. So in these two regions, if you see this solar insolation kilowatt hour per meter square, this potential is much more in the southern and western regions when compared to the other uh, regions in our country. That is the reason why the installed capacity, this is as of 2021 installed capacity. uh, if you see this megawatt installation, the installed capacity is much more in the southern and western region because of its huge potential. So we can get this solar potential data. If you want to do analysis, you can get this solar potential data from the link which I have mentioned at the bottom, solar irradiation European website. So you can get the hourly data, you can get daily data, you can get monthly data, you can get a typical meteorological year data as well from this thing. And when you get this data from this particular website, you can get the solar radiation as well as temperature of any location in the world as well from the website. So you take the location of your interest, you can find out whether it is suitable to install a power plant at that location or not. So normally uh, when we are investing in this solar, we will see that our payback period will be very within a short span of time, and we are able to get our investment, and we can get a profit out of it. So generally whenever we do analysis, so although we have daily, monthly, hourly data, generally we go with the analysis with the typical meteorological year. What does a typical meteorological year mean? So if you take a span of 10 years, uh, if you take a span of 10 years span, and in every year you consider the December any month. So every year you may have uh, so December from 2001 you consider till December 2010. So every year December month you take the average solar radiation, and similarly we take for all the months. So initially what we do is we select 1 month, um, you take the average solar radiation. Similarly for 2002 you take average. So for all the 10 years, because we are taking 10 years duration, so you take all these averages, whatever averages you are getting here, you take the overall average of it. So it can be of any value. And this value will definitely be between the minimum and the maximum of these values, because we are doing simply a mean. So whatever value you are getting at this location, at this overall average for the 10 years, you take this value, uh, you compare this value with these averages. So to which month average it is near. Suppose this value is around some 400 watt per meter square average you get, and somewhere around 2006 data, you are getting around 399 watt per meter square is the average. So you select this 2006 December 2006 data in your analysis. So what they do is, while taking the data, so in a typical meteorological year, whatever the data of Jan, Feb, and so on till December, November, December. So like this analysis they do for all the months of the all the years. So every so because why they take all the 10 years average of December is, the seasonal variation will be season will be same throughout every December, almost more or less the same. So here you get 2006, which is close to that. So December 2006 data set of that data set will be taken while constructing this typical meteorological year. Similarly, if we do for now, if you do for January, so you do the same analysis, you may get some 2002 data may be very close to this overall average value. So you take that data. So overall data of the typical meteorological year will be formulated with the all the averages of the whatever the months you have taken, um, all the averages which are related to the overall average. So that particular month you will select, and you will they will form the typical meteorological year data set. So if you take this typical meteorological year, you can get a very optimal solution. Coming back to our next slide. So in India, we have, as I said, we can install the solar plants anywhere, like rooftop. So in India, we have the largest floating solar power plant, which is in Telangana of 100 megawatt capacity. This was set up by the NTPC. So this was is operational from July 2022 only. So what are the main benefits of getting installing this floating solar power plant? We will see in the coming slides. So even in India, there is a target to build 600 megawatt solar power plant on the Narmada River. If you see the solar installation trends in from the past 10 years, average rooftop installation, which is only the gray color one, uh, the rooftop installation has been increasing, but it has been increased in 2020 due to the COVID scenario. And if you see the annual large scale solar installation, large scale solar installation means solar parks, um, floating solar power plants. These are of very huge capacity. So all the huge plants cannot be set in the same year because of the funding issue and all. So once one of the solar power plant has been completed, they will start with the next one. So if you see from 2009, the trend of adopting the solar has been increasing continuously. So the first figure, um, which is on the left top, so this is on the rooftop solar installation of the solar panels. And the second one, right side, which is the on the rooftop of the railway station. So unnecessarily, instead of wasting the rooftop and purchasing the land for installing the plant, you can install it in the rooftop. So you need not invest much cost in purchasing the area. So whatever the second setup of this solar plant is there right side. So similar has been done in the Guwahati railway station to attain net zero. The bottom figure it is of a floating solar power plant. So this is the picture of this Ramagundam solar power plant, which is in the Telangana. Coming to the next slide. So the left top. So this one is used mainly in the military because they will be in the very remote location and they will not be in the same location throughout the year. So whenever they are going, they will carry with them. These are made up of thin film solar cells. So whenever you go anywhere, you can just they are very flexible. You can fold them. You can take them to the remote locations and there you may not be connected to the grid. So with the solar power generation they use it for the lightning purpose and for the fans, so such purpose they use even on the ships or cruise rooftops which are in the middle of the sea. um, the advantage is there will not be any shadow on these panels because it is in the mid sea, so maximum efficiency they can get, and even the temperature will not be more because of the cooling from the water. The temperature will be very with a minimum degrees in the middle of the sea, so heating will not take place, so losses are minimum. So these are two advantages where they can use it for remote locations. So these the third and the fourth one which are just shown. So these ways which are flexible ways of installing the plants. These we can call it as a mobile solar power plants. These we are adopting nowadays because the solar potential is somewhat varying from one location to other. So they are just moving to the remote location. They are just opening the panels and they can fetch the solar energy. So this is the India's largest power plant, which I said this Ramagundam power plant. It is of 100 megawatt capacity. So what are the main benefits of keeping on the uh, solar on the reservoir? So actually, this floating solar power plant was installed on the NTPC thermal power plant reservoir. Normally, for thermal power plants, we use water for our com- uh, for the cooling purpose and all, and that water again they take from the reservoir, they cool it, and again they will pump back to the reservoir after separation of the coal ash. So this water is not useful for any purpose. So if they are able to so when they have set up on this water reservoir, so initial land cost they are able to save. This was set up on around 600 acres of land. If 600 acres of land will be costing so much if we purchase, so this will be of free of cost. Next, with this setup, they are able to uh, avoid water evaporation of 32.5 lakh cubic meters per year. By generating 100 megawatt from solar, they are not contaminating the water, that is they are not polluting the water, and still they are conserving the water resources. Next, coming to the coal consumption, 100 megawatt generation will consume around 1.65 lakh tons of coal per year, that they are able to save. CO2 emissions they are able to reduce of 2.10 lakh per year. So they have set up this power plant phase wise, and if you see the top figure, top picture, so these are set up in the form of blocks. This is one. So like this, we have 40 blocks in a overall solar power plant. So we have um 40 blocks into each of 2.5 megawatt. So it is 100 megawatt plant. So they have installed 20 megawatt phase wise. Next, coming to the current scenario of electric vehicles. So we have this faster adoption and manufacturing of electric vehicle scheme, which was started in first 2015. So why they have started is they want to increase the adoption of eco-friendly vehicles, which is EVs. So initially it was started in April 2015. So whoever manufactures the electric vehicles, they are giving the funding as well as the incentives for them. So the plan has been extended in 2019 as well, which is in 2015 it is FAME 1 and 2019 it was FAME 2 scheme. In the FAME 2 scheme, they are majorly targeting on the public transportation, which is the city buses. So they are encouraging such kinds because if even the government will be in more profit if they are funding in such scheme public transport, and whatever their operational cost is there, they can reduce that. So FAME 2 is majorly targeted on this public transport. So our uh, India goal is we want to achieve complete electric in the public transport by 2030, and 30% of the private vehicles to be electric. If you see the trend of the adoption of electric vehicles from 2015 till 2020, the EV two-wheeler sale has been adoption rate has been rapidly increased, whereas the EV four-wheeler sale has been not much increased. If you can see these figures, in 2015 it is around 20,000. Here it is 2020 it is around 1,50,000. Almost you can say 7 to 8 times it has increased. Whereas coming to EV four wheeler, it is 2,000 in 2015 and it is 3,400 in 2020. It means the adoption rate is around 1.5 to not 2 also. Why there is a more adoption in two wheelers than the four wheelers? One reason is the cost of EV two wheeler is almost similar to that of the ICE engine two wheeler. If you take an Activa, you can get for around 1,30,000. At the similar price, you are able to get EV two wheeler as well. And the operational cost, that is the running cost, the of petrol is more when compared to the EVs. That is the reason people are more adopting to EV. That is the two reasons why EV two wheeler adoption rate is more. And one more reason is EV two wheelers we use mostly for the uh, local purpose. So we go mostly around per day around, if you go around 60 to 100 kilometers also in one charge. Today's EVs are able to give 100 kilometers and 120 kilometers also in one full charge. So instead of going through an petrol vehicle, they are going towards the EVs. So much of saving in the cost. That is the another reason why they are adopting to EV two wheelers. In EV four wheelers, we have so much price difference for an ICE vehicle versus an electric vehicle. So almost we have around 8 to 10 lakhs of difference for the electric vehicles. So initial investment cost itself is high for an EV four wheelers. So we will come up how to overcome these challenges and how to encourage EVs for four wheelers as well. So if you want to have a look at the global scenario of the EVs, you can just go through the link which is present at Global Electric Vehicle Outlook. Next, our Prime Minister wrote at COP26. This is an United Nations Climate Conference of the Parties, which was held in November 2021. Um, Coming to the Coming to the oath taken by our Prime Minister, he has taken the five pledges, which are India will increase its non-fossil fuel energy capacity to 500 gigawatts by 2030. Non-fuel fossil fuel means it is renewables. So as of today, renewables capacity we have seen in the initial stage, which is 166 gigawatt. We are in 2022, and by 2030 we want to adopt it to 500 gigawatts. So this difference we must be able to tackle at a very faster adoption rate. Next, India will meet 50% of its energy requirements from renewable energy by 2030. So, in India, we have an overall energy consumption per capita per year. The consumption of energy is around 1.137 trillion kilowatt hour. So, you assume how much you can think of it, how much high the energy consumption is. So you want to achieve 50% of it from the renewables. And India will reduce the total projected carbon emissions by 1 billion tons by 2030. And India will reduce the carbon intensity by 45%. We are now at 35. We want to reduce to 45%. And by 2070, India will achieve the target of net zero. It means, as I said in the initial, whatever energy we are consuming in the 1 year, we should be able to achieve it, generate it from the renewables. So energy consumption is 1.137 trillion kilowatt hour, and our capacity is only 166 gigawatt. With 166 gigawatt, if you assume we have 166 gigawatt of renewables, and if you assume that we have around 8 we have around 6 hours of more sunlight per day, and if this is there for 365 days, so this will be the total energy generated. And still there will be a deficit of energy which we have to meet from renewables. So 166 into 6 into 365, uh, you can get some kilowatt hour of energy which is very much less than the 1.137 trillion kilowatts. So if you see here, even the government of India is much more interested in renewables, adopting renewables, reducing carbon emissions, and we want to attain net zero. And coming to the architecture of power grid, so the left side one is a traditional power grid, and the right side one is the smart grid. So the main difference between the traditional grid and the smart grid is, first thing is communication. That is a two-way communication of information, which is due to the IoT and the smart meters. So in the traditional grid we have a conventional meters where from remote location you are not able to fetch the data. In smart grid we have the smart meters where you can view the data of anywhere in the world, from anywhere in the world, using this IoT technology integrated to the energy meters, which we call these as the smart meters. Apart from these two aspects, the main things which are integrated to the smart grid is renewables, mainly the solar and wind. So initially we have seen out of 166 gigawatt, 60 gigawatt is of solar and 41 gigawatt is of wind. So these two are the major contributors to the renewables. Apart from these two are the generation, and the EV load has been included in the smart grid. This is the load side. So for the existing grid, we are including integrating some generating sources, as well as we are integrating some loads as well. So in order to avoid the grid congestion, so if what happens if you are increasing only the generation in the grid, so overflow of power will be taking place, and you need to discharge that power in the resistor banks in order to avoid the congestion. What happens if there is no renewables, that is generation you did not increase but you increased the load, so more congestion will be taking place in the grid. So we, with the integration of renewables and EVs, we have to manage, we have to see in such a way that the grid stability is not violated, and the operating of the grid is within the stable limits. So the thing is like, grid is not congested, and we have to ensure the safe and stable operation of our power grid. So what is the need for adopting renewables and electric vehicles? The main aspect is cost and pollution. Renewables investment cost is high, but operating cost is low. For electric vehicles as well, the investment cost is high, the operating cost is low, and the pollution from solar and electric vehicles, only during the manufacturing you will get the emissions, GHG emissions. During this operating condition you will not get zero emissions, both the solar and renewable. So with the India targeting by the government of India, Prime Minister and the Prime Minister fi- uh, adopting towards the renewables and the EVs. These are the two main aspects, and these two renewables and electric vehicles, they have the significant future potential in the research and the development. So the need for adopting solar. So these are the some of the benefits why we need to adopt solar. First thing is, for power generation you won't utilize water, so we are avoiding water pollution. Next, we are conserving hydro resources because of placing the solar power plants. No greenhouse gas emissions during its operating, very minimum during its manufacturing. Mitigating climate change and the overall per unit cost of electricity, we are able to reduce. This I will show in the next slides. Like, if you are generating power from the conventional non-renewable energy sources, the per unit cost will be around 6 to 8 rupees. Whereas if you are generating from renewables, you will get at 2 to 3 rupees per kilowatt hour. Next, while solar generating the power, there will be no noise pollution, and minimum losses will be there because there are no moving parts in the solar power generation. You can keep the concentrated solar power plant where the panels will be facing towards the sun, in the direction of the sun, but the cost of investment in it is high, so the output will not be much more difference if you are generating through the concentrated solar power plant or the fixed solar power plant. So most of us adopt the fixed solar power plant. And the thing is, and the other thing is, it is an inexhaustible energy source. It is available plentifully in the world. If you see the solar energy versus thermal energy cost comparison, so in 2018, including storage, it is 13.8 rupees per kilowatt hour, whereas the thermal is 5.5. As I said, the thermal is keeps on increasing. If you see, but in 2022, the price is 10.5 for solar and 5.9 for thermal, which is coal based. In the future, in the 2030, the estimation is that 6.4 will be the solar price, 7 will be the grid price. The solar is including with the storage. The major cost is of batteries itself. If the battery is not there, and if you are using grid connected solar, this 6.4 is going to still reduce to around 4 to 5 rupees in the coming future. And even the battery costs are reducing day by day. So these solar have this very much uh, potential of adoption. So here you can see on the left side the solar price has been decreasing over the past 6 years, whereas the thermal price has been increasing. And if you see the cost of the PV module from 1977 to 2020, it has been drastically decreased because of the advanced technologies in the development of the PV modules. So when the cost has been reduced drastically, the initial investment cost will also reduce, and even further in 2030 as well, the cost will come down. If you see the solar versus thermal CO2 emissions, you can see from coal life cycle CO2 emissions, it is around 1041 tons of CO2 per gigawatt hour, whereas from solar it is only 39. You can see a very huge difference between coal and as well as the solar. So this much amount of uh, CO2 emissions we are able to reduce if we are shifting from uh, non-renewables to renewable power generation. That is why government of India is majorly targeting towards the renewable sources. So other sources of non-renewable and renewable comparison I have given just for your reference. And if you see the indirect and direct emissions of CO2 from coal, the direct emissions is much more than the indirect emissions. Direct emissions means during its operation, whenever we are generating um, the power from the solar, power from the coal. So those comes under the direct emissions. Indirect emissions comes in solar power plants we have boilers. All these manufacturing process also leads to some emissions. Those are indirect emissions. So if you see this solar, we don't have any direct emissions while its generation, but during the manufacturing of the modules, we have some indirect emissions. Coming to the need for adopting the electric vehicles, um, we have the lower running cost of electric vehicles. That comparison I will show you for the electric versus the conventional vehicles. Maintenance cost is very minimum because we don't have rotating parts as of the IC engine. Zero tailpipe emissions. Uh, Whenever you are going through an EV, you have, I think you have seen some of the EVs. It does not have an exhaust pipe for this. So there is no emissions from the EV, no noise pollution, higher lifetime mileage. If you see the lifetime mileage, IC engines will able to give 1,30,000 miles over its lifetime, whereas the electric vehicles are able to give 2 lakh miles uh, over its lifetime. So the mileage you get with the EV is much more. And other aspect is the efficiency. If you can see on the graph, with the increase in speed, of an ICE vehicle, the efficiency is decreasing. Suppose your speed is around here of 1500 rpm, so your efficiency is 35%. So if you see the 1500 speed with the EV, your efficiency is around 90%. Next, coming to if you are moving with higher speeds, normally we have a we call it as a uh, threshold speed like that. So if the speed is too low or too high for an ICE vehicle, the efficiency will be much lower. You can see here. But if the speed is at its threshold value, you can see the efficiency is around 35%. Whereas in EVs, irrespective of the speed, whether you are at lower or higher speeds, the efficiency is remaining constant. It means during the traffic conditions as well. So in traffic conditions, you will be at very low speed. So efficiency is less. Whereas for an EV, the efficiency is more, even during low speeds. You can see if this is the low speed, you will be there at the traffic condition. So efficiency is less, whereas for EV, the efficiency is more. This is one more advantage of uh, EVs. Coming to the cost comparison of a four-wheeler IC versus EV, um, I did not take the comparison of a two-wheeler because the two-wheeler cost is more or less the same for an ICE vehicle, that is petrol vehicle versus EV vehicle. Um, Coming to the cost aspect of four-wheeler, you can see the engine cost is three, uh, three index is three, whereas the battery cost is 8. So this difference is much more for an IC versus uh, EV. That cost is going to reduce here in the coming future because of the advanced battery technologies. So instead of 8, if it is coming to 4.3, so there is a huge reduction, and the difference here is 45%, and in the future it will come to 9%, and by 2050 this difference will come to more or less 2 to 3%. It means how our two-wheeler EVs and petrol vehicles are available similar cost, so the cost of these will be more or less similar. So when the initial cost is less and the initial cost of ICE versus EV is more or less the same, and the running cost of EV is less, people will start adopting to the EVs. So with this vision, we have to start much more development in the EVs. Next, if you see the cost comparison of the batteries from 2010, the battery price in dollars per kilowatt hour, it is coming on reducing. By 2022, we are here at this point. So from 12 years, it has reduced from $1,000 per kilowatt hour to around 200. It has reduced. So almost 80% reduction in the cost has been done because of the advanced battery technologies. In the future, it is still going to reduce by 2030. If you see the petrol and diesel prices, these prices are keeps on increasing from the 2002 to 2022. So if you are moving towards the ICE vehicles, your operating cost for ICE vehicles keeps on increasing in the future, whereas I can show you. We are here at this initially 2000. Now we are in 2022, and in the future of 2030. So the battery cost here is very high, and it is going to reduce by 2030. This is of battery. Coming to the petrol, initially 2000 it is less. So even in 2022 it is less. In the future it is going to increase. So at some point of time, uh, the price of EV of electricity cost will be much lesser, and operating cost of the EV is less when compared to that of the. So after some years, these EV costs will be reducing and the petrol costs will be more. At that time, people will start much more adoption to electric vehicles. Next, if you see the CO2 emissions for the solar, petrol, as well as diesel vehicles, we have three emissions. All the emissions are considered, which is TTW, means tank to wheel efficiency. It is nothing but whenever you are filling the fuel in your tank, and it is till it is what we can say, like till the movement of the vehicle is completed and these are exhausted from the vehicle, uh, we can see the TTW emissions from petrol, diesel is more, and for the battery electric vehicle it is zero. It means tank to wheel conversion efficiency is much more. Like emissions is more for the diesel vehicles. So from TTW includes from filling the tank in the fuel to the disposal of the combustion components. Next we have WTT, which is well to tank, means from the process of digging these energy sources to the instant we are filling it to our fuel tank. These are the emissions which are there for petrol and diesel is less, but for battery electric vehicles, this is more because of the lithium ion batteries, and even manufacturing. All these are combined. So WTW is nothing but TTW plus WTT, means from well to wheel overall is nothing but well to tank and tank to wheel. So if you see the overall, we have to consider the this one, which includes emissions from initial extraction process till the disposal. So if you see, the emissions is less for the battery electric vehicles overall. So that is the reason why we are adopting to the electric vehicles. And coming to the CO2 emissions, I am comparing with the Volkswagen car, which is of diesel run, petrol run. This is charging the e-vehicle with the grid. This is the charging of e-vehicle with the 100% renewable, which is solar. So if you are doing like that, uh, during the production, the CO2 emissions will be indicated in blue color, and during its operation, whenever we are operating the petrol car, that emissions are indicated in green. If you are charging your e-vehicle with the renewables, then the emissions are less. If you see, the overall emissions are less. If you take these two, one and two, what you can observe is, if you are adopting battery electric vehicles, the emission is less, that you can say from the first one. And if the same battery electric vehicles, if you are charging from renewables, your cost is less, as well as the pollution emission is very less. So you need to integrate the battery electric vehicle with the renewables. So this is the main motto. This is the main reason why we have selected, why I have chosen to uh, explain on these battery electric vehicles plus renewables, which is nothing but the EV charging infrastructure for the green mobility. I hope you got a clear idea why we are adopting the battery electric vehicles and why we are integrating the renewables. Next, if you take this person, this is a small example where he wants to travel 50 kilometers every day you assume that the petrol car is giving 16 kilometers per liter mileage, and this electric car is giving 8 kilometers per kilowatt hour. So in order to travel 50 kilometers, you have to take 3.125 liters of petrol. It will cost you 250 rupees per day. If you are going through an electrical which is of 6 rupees per unit, this is of grid price. If you are doing through solar, it is still less, around 3 rupees you can get. So 6.25 units you have to consume. So overall per day is 37 rupees only. So which one do you choose? Whether you choose going of spending 250 rupees per day or 37 rupees per day. You can ask a question that initial cost is high for this electric vehicle, so that may compensate this. We will in the further slides we will see the analysis with the initial cost along with the operational cost. So So we have three different types of solar panels, which is monocrystalline, polycrystalline, and thin film. So normally, we use monocrystalline because the efficiency is high. So the main difference between monocrystalline and polycrystalline is in monocrystalline we will use only single solar cell. The solar cell which we are using. Uh, the solar cell in is of same single crystal solar silicon we use in monocrystalline, whereas in polycrystalline we use multi silicon crystal. Thin film I showed that we use for this army and military purposes, where we have this flexibility of bending and all. So you can see the rightmost top is of monocrystalline. The bottom one, right bottom is of poly, and left side is of thin film. Normally, thin film efficiency is usually less. Coming to the major parameters that impact the solar performance, one is the tilt angle, which is nothing but inclination, then latitude, climate conditions, the orientation which we keep, and the effect of shadows. So normally we keep it the inclination of 30 to 45 degrees tilt angle we keep, uh, and orientation normally we face towards the south direction. Latitude if you take normally the best if you see uh, if a person wants to compensate an electricity bill using solar, so person who is in northern region has to install more solar capacity than the southern region because of this latitude. So if you want, that is the reason why even in the southern regions the solar installation is more. So in general, if there is a solar plant of 1 kilowatt capacity, it is able to produce 5 kilowatt power in per day if there are 5 peaks an hours. 5 peaks an hours means like uh, peaks an hour we consider as 1000 watt per meter square, and overall in a day if that much amount of radiation is able to get uh, over the 8 to 10 hours, because whole 8 hours we may not get constant radiation, it goes on increasing in the afternoon and again it decreases. So uh, if this solar radiation over the whole day we are able to get, which is equal to 5000 peaks an hours, then we are able to generate uh, 5 times 4 to 5 times the installed capacity. So normally we get the peak output of the solar at 1000 watt per meter square. So this is the analysis which we have done for the net zero building. If these are the appliances which are present and uh, power rating of the appliances, these number of appliances which are present, how many hours they are operating. So overall, uh, uh, total load connected is 80 kilowatt, and per day the consumption is 827 kilowatt hour. For that, we want to make it net zero. We have designed the solar plant So if you see here, uh, which is a grid connected, we did not consider the battery because the battery cost itself is high. So we are assuming that in our building the peak demand is 50 kilowatt, and average we are getting 8 hours duration. So we will get government subsidy. We have taken monocrystalline. So taking all these parameters into consideration, and if you we have designed the plant, we need a capacity of plant is 129 megawatt to make our building net zero to meet all our the loads over the 1 year duration. So if you are purchasing the same amount of energy consumption, so per day you are consuming this much into 365 over the year. If you are consuming that much energy from the grid, this is the cost which you have to pay to the grid. Okay, so if you are investing in solar, then you can able to get your payback within 1.1 years, and after that you are getting your investment return as well. You can gain a profit of uh, around 7 crore rupees. So this is the profit you can, this is the profit also you can get if you are installing through installing solar. So initially, next, coming to the challenges in solar, we have seen that initial cost is high, that we know. But if you are installing, I have shown what is the future benefit, because the lifetime is 25 years for the solar panel. Next, coming to the efficiency, we have seen the efficiency of different types of panels, which are of maximum. We have 19% efficiency of monocrystalline. In order to deal with it, the new technology of solar panels came, which is of PERC solar panels. We will see about that in the next slides. Next, we have the intermittent nature of the solar energy generation. Because of that, we are unable to generate much more energy, and we are able to generate only during the day hours. So to deal with it, research is going on in the Stanford University, where they are trying to generate power from the solar panels during night time also. You can go through the below link, which I mentioned, to if you want to much more explore about this power generation during night times. And land availability. So initially, if we have to keep much more land investment. So we have seen floating plant. If you are investing in that, there is no land cost. You are able to save so much of energy, so much of cost in it. Next, how to deal with the high manufacturing cost. So as of 30th November, our manufacturing capacity is 15 gigawatt per annum, and we want to reach our target of 280 gigawatt by 2030. And our capacity is as of now, our installed capacity is 60 gigawatt only. So around 220 gigawatt difference is there. So if we are able to do made in India products, we are able to get it at less cost. So initial manufacturing cost we are able to reduce. Next, this is the new technology of PVRC panels, apart from monocrystalline, polycrystalline, and thin film. So with this, we are able. This is the improved version of monocrystalline cell, where we have added the passivation layer. Because of that, we will get three advantages. One is light is reflected back into the cell, so that the solar radiation absorption will be more, and whatever the greater wavelengths of light, they will be reflected. Because if we have a greater wavelengths of lights, the disadvantage is because of greater wavelength, heating of the panels will takes place. So with this passivation layer, if we are able to reflect that, heating of panels will not takes place, and we are able to improve the efficiency. And next is, because of the passivation layer, uh, energy density of the panel we are able to increase. So uh, like this, we are able to come up with the new technological developments in the solar panels. so that we are improve the efficiency and the overall cost we are able to reduce. So but these panels are slightly expensive because of the addition of the passivation layer, and 5% efficiency we are able to increase. So around 25% efficiency you can get through this PRC panels. So we have addressed the challenge of low efficiency as well. So the main difference between this monocrystalline and PRC panel is, you can see here, the only difference is the passivation layer. So here directly light used to pass through it, whereas it is reflected back here because of this passivation layer, and light is absorbed, and we are getting a second we are able to generate more. Next, this is one case study which you can take. Uh, Assume all the conditions are same for all the solar panels. uh, uh, like the rating of the solar panel is same, they are placed in the same environment, the type of solar panel is same, the inclination or the tilt angle which we kept is same, orientation is same for all the types of configurations. If you can see these two, A, B, the first configuration A is on rooftop. The flooring of it is a concrete. The B, the second one where the floor has a grass, and the third one where we have a gravel. Fourth one D, which we have a water at the floor. So generally, if we have a grass compared to the concrete, the efficiency will be more. So efficiency of this will be more compared to this, because whenever the grass is present, the heat will be absorbed, and uh, much temperature will not be much more when compared to the concrete, because concrete will absorb the heat and it will slowly release the heat. So because of that, heating of panels will take place, and you are able to get efficiency will be reducing. For the panels, PV modules, to generate higher output power, so it should have higher irradiation, but the heat must be minimum, then only it is able to give more output. So you can take a case study also like this, with the different conditions, uh, where you can if A, B, C, D, we have I have shown just as an example. You can take case study, and you can see for the same conditions which compared to A and B, B will be giving more efficient than A. So other case studies you can explore if you are interested with that. Next, coming to the challenges in EV, the main challenges in EV is six, lack of charging infrastructure, because we have petrol pumps very every 2 to 3 kilometers, whereas if you see the charging stations, on an average for 50 kilometers, 100 kilometers also you find rarely a charging station. So because of that, people are not adopting much EVs, long charging time. With petrol you are able to instantaneously fill your fuel, whereas with the EVs, for charging the battery you are taking 2 hours, 3 hours, although we have different types of different levels of charging, AC charging, DC fast charging, still it is taking minimum 30 to 40 minutes using the DC fast charging to charge a 30 kilowatt hour battery, so which is of very huge time, where the customer is not interested to waste that much amount of time only for the refueling or recharging. Next is the limited range of batteries. If you see the Tata Nexon 30 kilowatt hour battery, you can get around 250 to 300 kilometer range if you are going with a constant speed. And if you are normally we prefer four wheelers whenever you want to go for a long distance travel. In such cases, you are not able to cover to larger distances when compared to the conventional vehicles, and the high initial cost of vehicles are there, and some of the safety aspects. Because of these reasons, the adoption rate of EVs is less. We should be able to mitigate that challenges. So if you want to increase the range of traction batteries, so the solution is you can design an energy management strategy where you can improve its energy efficiency, proper cooling techniques where we can reduce the battery temperature, because the temperature is the key parameter which affects the battery performance. Life cycle improvement of the battery we can do, so that we can get for a more mileage. Next, coming to the long charging time, if we can reduce the internal resistance of the battery, the charging time of the EV you can reduce. And next, high purchase cost. To overcome this, um, we can use advanced battery technologies, and we are getting lithium air battery technology, graphene battery technology as well. And even with the, as we have seen, the battery cost has been reducing day by day. So this will reduce our overall EV cost, which will come close to the internal combustion engine initial cost. So you can go to this website where you can estimate how much of cost you have to spend for an this much distance travel, how much pollution will be emitted. So you can go to the link which I have given here. This link, if you go, you can calculate some of the parameters which your which type of EV you need to prefer, what is your budget. So all these you can go to this website, and you can decide accordingly whether the EVs are beneficial or not. And definitely EVs are much more beneficial than IC in the coming future. For that, we have to develop the advanced technologies from now itself. Next, this we have implemented in our which we are doing in our research purpose also, where we have taken this PZDM node MCU. We are able to get this PZDM 004T is an AC sensor. We are able to fetch these parameters of electrical parameters through to the remote location using this ESP8266. So this is an ESP8266 microcontroller. With this, we are able to fetch a remote location data to our cloud. Using this Wi-Fi, we are able to fetch to the Google Sheets for our data analysis. Even you can first we are doing monitoring, then we can extend it to the controlling as well. We can monitor and control anything from anywhere because of the integration of this IoT. Next, this is the data, sample data which I am showing you. This is the test data where we are getting voltage, current, power, energy. This will be the cumulative. This energy is the cumulative energy, frequency, then the power factor. I think as an electrical, in an electrical, these are the main parameters which we require for any analysis. If we are able to get these parameters to the remote location and you can do a proper data analytics, then the you can solve many challenges in the electrical sector. And you can using the relay control, you can control it from the remote location as well. Next, till now, whatever we have discussed is regarding the solar, regarding the EV charging, regarding the EVs. So we are integrating, as I said, why we need to integrate BEVs with the solar. This is the thing where we are integrating solar with the EV charging station. This combination is the main thing which will drastically reduce our dependence on fossil fuels, although the EV demand is increasing day by day. If you are able to take 10 solar panels of 30 watt, so uh, so assume we are taking 10 solar panels of 30 watt each. Um, it is of 3000 watt rated capacity, and per day if you take 5 solar hours also, how much it is able to generate 15,000 15,000 kilowatt hour. So you can generate 15 kilowatt hour in a day. Okay, with 15 kilowatt hour into 365 days, if you generate, so 1 year you can generate so much of energy, and with that energy you can drive more than the 21,000 kilometers per year. It means you are running for a free of cost. The fuel which you are getting is of free of cost. Next, whether you need to connect the solar charging to the grid or you need to keep it as an off grid. Off grid means standalone system where we keep a battery as a backup. So always grid connected system is cheaper compared to the off grid system, because when you are connected to the grid, if you are generating in excess, you will give it to the uh, grid. If you are generating in deficit, you will uh, withdraw from the grid. So that flexibility will be there when you are connected to the grid. Suppose if you are generating more and there are no EVs coming on that day to charge, so what you will do? That energy will be wasted if you are off grid. And even if you are generating less and EVs are more, you can't give reliable amount of power to the customer. That is also an issue. So if you are and again with the off grid, you have to keep a battery, which is a major cost. So if you go with the on grid, we have so much of flexibility, and reliable power can be supplied to the EV customers. If you see this petrol versus EV running cost, assume you are traveling through an fuel car, grid charged EV, solar charged EV of 14,000 kilometers. So overall, if you see, uh, compared to the fuel car, this you invest. First, we will go with the investment. So if you go investment is high, here you are not investing anything. Here also you are investing for the EV same amount. Next, after investing, we do for the fuel cost. So if you go for the fuel cost, because we are operating, fuel cost is more here. Here it is less with the grid charge. If you are charging from the solar, it is much less. So solar charged EV is much better than the grid charged EV, which is much better than the fuel powered EV. So taking these two initial investment costs as well as the operating costs, if you are combining these two, this is the overall cost which must be paid by the consumer at the end. So we will see how what will be the saving. So if you take the saving, if you see total benefit 10 in 10 years, there is no benefit with the fuel car, whereas with the grid charge the benefit comparative saving, this is 20,800 euros, whereas for this solar charge you can have much more benefit. So solar charge GV is much more beneficial than the grid charge GV. That's why after adopting to EVs as well, we have to integrate renewables in order to get much more uh, economically benefit in the future. Next, you can see this is the one case study where the person has traveled 84,995 kilometers using his Tata Nexon EV, and total including all the costs of charging cost, consumption cost, service cost, all the cost, it came up to 1 lakh 1686 rupees for 84,995 kilometers. So for 84,995 kilometers using EV, he has spent around 1.01 lakh. Okay. If you want to travel this same distance, 84,995 using your conventional vehicle, if you are getting an mileage of 10 kilometers also, 84,009 8,499 liters of petrol you have to fill, which is multiplied by 110 rupees of petrol. You can estimate this cost will be around more than approximately equal to 9 lakhs. So the running cost with the EV, with EV, your cost is around 1 lakh, whereas with IC engine, your cost is around 9 lakhs. So this difference of 8 lakhs, if you are able to invest in initially only, then you are able to uh, get more profit for the uh, after you reach a certain driving range, after traveling a certain distance. So if you see 8 lakhs difference initially, if you keep later on, you can get much more benefits with the electric vehicles. Next, uh, the thing is, we want to achieve the net zero overall. Uh, Even India is targeting to achieve net zero. For achieving that net zero, we are adopting to these renewables and EVs. These are some of the key milestones. Like we are not setting up some of the uh, new coal-based power plants from now onwards. 60% of car sales we want to keep electric, and 50% heavy trucks. And from 2035, we don't want to start manufacturing new IC vehicles. So these are some of the things which we have to adopt so that we can achieve our net zero target by 2070. So we, if you the roadmap for global energy sector, so net zero target by 2050, you can go through the link which here mentioned here. So you can have what are the ways we need to adopt, what are the uh, areas which we have to invest to net attain net zero. All this you can get a very uh, clear idea. So thank you.
Yes, sir. Thank you, sir. Students, feel free to ask doubts.
I will just
Sir, is
stop my
floating
presentation.
solar plant,
Yes.
sir, is floating solar plant affect that aquatic ecosystem, sir? It-
See, uh, whatever that NTPC has set up the floating solar power plant, they have set up on the thermal power plant reservoir, right? So if um, does the aquatic life can be sustainable in that thermal power plant reservoir? Because whatever the coal ash and the polluted water is coming from the thermal power plant, they will again release there itself, right? So um, the the aquatic life cannot sustain in such environment, and in such areas they are building these floating plants so that it will not affect them as well. I hope I would able to answer to your question. Is it clear for you?
Yes, sir. Clear, sir.
Any other queries or questions?
Sir, recently we are seeing that so many electric vehicles are catching fire during
Yes,
charging and discharging.
yes.
What are the reasons for that, sir?
So normally this the main reason is that overheating of the batteries. So we can keep the heat sinks. That's what I said. Proper cooling techniques we can adopt. Um, my major area does not go much into the safety aspect of the EV, but the main reason I can say is like due to the much more heating.
Sir, got it, sir.
So for that, the solution we can keep is like uh, if we can keep that uh, heat sinks or uh, in power stations, we will have that heat detectors where if the temperature is more, uh, we can keep temperature sensors as well when the temperature is exceeding around 45 degrees, 50 degrees. So it has to give an indication so that you will be alert before itself, before it catches the fire, so that we are able to save the life of a person. So mostly now many are working on the safety aspects of the EVs as well, because uh, apart from the cost, the person life is more important whenever you are traveling. So that is one of the drawback, major drawback, why the adoption rate is much less of EVs.
Got it, sir.
Okay. Any other questions?
Sir, if it is possible, run more time on electric vehicles, sir, like a petrol vehicles, much more kilometers.
No, the thing is, with the existing, if you take an example of Tata Nexon, so 30 kilowatt battery it has. So you can add a battery to it, right? Like instead of 30 kilometer, um, you can keep a 60 kilowatt hour battery also. That will increase the range, but that is not the feasible solution, because you can increase the range of electric vehicle by, as I mentioned, you can increase it by proper energy utilization efficiency of the vehicles. That is the first thing. And you can improve the life cycles of the battery. So uh, instead of this you can say fast discharging or rapid discharge of the vehicles because of improper maintenance of the batteries, the life cycle will be affected. So as I have seen shown you in solar, same panels you have, but with the concrete and the grass, the efficiency difference is there. In the similar way, same batteries, if you are placing in different environments, um, we have to see, we have to see to improve its range rather than adding the battery capacity. The main disadvantages of adding battery capacity is cost will be too much of high, because in an EV the battery cost itself is too high. And the other reason is whenever you are adding battery to the extra, whenever you are adding extra capacity, means increasing the capacity of the battery, the weight of the battery will be uh, adding to the EV weight. So whenever the overall weight has been increased, so the mileage of the EV will reduce. So the purpose of you adding the battery to increase the range indirectly you are reducing with the due to the addition of the battery weight. I hope you understood.
Yes, sir. Understood, sir. Got it.
Any other?
Sir, I think no more questions from student side, sir.
Okay.
Let us end up with the session with vote of thanks, sir.
Okay.
We thank our speaker, Bhanuganesh sir, for spending your valuable time with us, for sharing your knowledge with us, sir. The information you shared with us gave us more knowledge in the domain electric vehicles charging. Thank you, sir.
Okay. Thank you. Thank you, everyone.
Sir, we'll be in touch with you, sir.
Yeah, sure.
Thank you, sir. This is the end of the session.
Thank you.
Students can leave and we'll have a seminar ahead in coming weeks. Thank you all.